Hi everyone, welcome to your lesson on seasons. So seasons are amazing. Seasons don't happen everywhere across the earth. And we are going to learn about seasons as the Northern Hemisphere experiences them. So that's where we live. So we have fall, winter, spring, and summer. Not everywhere on earth has those seasons. And so we're going to learn about why we have those specific seasons. First thing to know is that seasons happen because of the Earth's tilt. Earth's axis is tilted 23.5 degrees. And because of this, the sun hits the Earth at different angles, causing different seasons in different hemispheres. Here's a great diagram of the Earth's tilted axis. So instead of it being straight up and down, it's tilted slightly, 23.5 degrees. And because of that, again, the sun's rays hit the earth at different angles. I want to clear something up because there's a common misconception surrounding seasons, and I want to make sure everybody knows that this is the reason that the reason seasons happen is because the earth's axis is tilted and not because of the way that the earth orbits around the sun. So a lot of people think that winter happens when the earth is farthest away from the sun. Remember, that's aphelion, farthest away. And that summer happens when it's closest, which was perihelion. That has nothing to do with seasons whatsoever. Seasons happen because the earth's axis is tilted, not because of how far away or close the earth is to the sun. It's all about the tilted axis. Okay, so here's a great diagram that shows us summer and winter. So during the summer, you can see that at the top left, the earth is tilted. During the summer, there's more sunlight hitting on the northern hemisphere because of the way earth is tilted. And during the winter, earth is tilted the same way. However, you see that where the sun hits on earth is different. So now there's more sunlight on the southern hemisphere. Here's another diagram that shows all seasons. So the sun is in the middle. We'll start up at the top. You can see Earth's axis is tipped. North Pole, Northern Hemisphere, South Pole, Southern Hemisphere. And you move over to summer. You can see that there's more sun on the Northern Hemisphere. And on the right-hand side, look at winter. There's more sun in the Southern Hemisphere. If you look at spring and autumn, you can see that exactly half of the earth is sun on each of those. So the part of the earth that we can't see for autumn is all sun. The backside, which we can see, is all shade. So when you have half of earth all sun and the other half all shade, that is called an equinox. Those are the days where you have equal day and equal night. And that happens when the sun crosses directly over the equator. There's a spring equinox and there is an autumnal equinox. Spring equinox is around March 21st or 2nd, and the autumnal equinox is September 22nd or 3rd, so that actually just happened. So you have your equal day, equal night, and in the fall after that, you start having longer nights. In the spring, you start having longer days, which is why it stays lighter longer in the sun. Here's another diagram of the equinox. So you can see the sun's rays hitting Earth. They're hitting directly over the equator, which allows exactly half of Earth to be covered in sunlight and the other half to be shaded. So that's day and night is what you're looking at. Okay, so Northern Hemisphere seasons. So June 21st or 2nd is the summer solstice. That's the longest day of the year. That's when the sun's angle and Earth's tilt create the largest amount of daylight for the Northern Hemisphere. December 21st or 2nd, that's the winter solstice and is the shortest day of the year. So that's when it gets dark really early and it doesn't get light until later. So that sun's angle and the Earth's tilt creates less daylight. The winter solstice. This one right here. Don't look at it like you would an equinox where it looks like it's equal day, equal night. Look at the equator. So if you look at the equator, which is the middle line, and you look at that angle up from the middle line, if you were to shade in the whole top left part above the equator, that's where we're talking about. That's the sun's rays in the northern hemisphere. Look at the winter solstice diagram and you look at the equator and you were to shade in, it's like a pizza shape above the equator, only where it's daylight, you can see that it's a much, much smaller chunk than in the summer solstice. It's an acute angle. The equator and the line that's made between daylight and night is very small. And during class, I'm going to go over this because I want to make sure everybody understands.